if you are taking two integers a and b, a should be greater than b. So a will be the dividend. The bigger one will be the dividend. Remember this, okay? So if I'm taking two integers a and b, so and a is bigger, so a is dividend. B will be divisor. We will be taking two numbers. One is as quotient and the is remainder. Okay, this is the formula you will be seeing, PQ plus R, okay, which is Euclid's division lemma. Okay, and R, yes, R value will be less than B and equal to or greater than 0. Okay, this is your Euclid division lemma. Idea. Euclid's division lemma states that for any two positive integers, say A and B, there exist two unique integers, say Q and R, such a way that A is equal to B plus R. Let it be R. Okay, so understood? A is the dividend, B is the divisor, Q is the quotient, and R is the remainder. Okay, any doubt in this? I don't think so. We are having doubt.
No, ma'am. Not.
Okay. Now here, Euclid's division lemma is nothing. It is divisibility of integers only. Okay, about divisibility of integer. So when a positive integer a is divided with another positive integer, we are assuming it as b. Okay. So when it is not fully divided, it leaves a remainder. Okay, so remainder should always be less than b, the dividend. Okay, when we used to study polynomial, then also I used to tell that when your division is finished, when the R value is less than B. So that is. Now here you will get 2-3 questions only, and maybe based on these type only you'll get another type of questions, that is the application of Euclid's division lemma. Okay, and these 3-4 questions are very important. Understood, Shazan? Prepare them. Okay, one among this will always come. Okay, it's a general case. A question comes from here. Okay, now show that every positive even integer is of the form 2q. Now, what is the question? Now, you have to show that every positive even integer is of the form 2q and every positive odd integer is of the form 2q plus 1, where q is an integer. Okay, q is an integer. So you need to show that every positive integer is of the form 2q and every positive integer is of the form 2q and that every positive odd integer is of the form 2q plus 1. Okay. Now, if we are having two integers, we'll take let a and b be any two integers. Okay. So if we are taking any two integers a and b, so what we will do? When we will dividing, let a and b be two integers. Okay. Now, when you take two integers a and b, so what is there? Let us apply division algorithm. Okay. Sorry, Euclid division lemma. A is equal to bq plus r. Okay, where r value should be greater than equal to 0 and less than b. This is how. This is by Euclid's division lemma. Okay. Now we have got this. Okay. Now what? Let us put b as is equal to 2. On putting b is equal to 2 in, name it as equation 1. In equation 1, we get what you will get. Instead of b, you are putting 2. So a is equal to 2q plus r, and what else? R value will be greater than equal to 0 and less than 2. Okay, this is your second equation. Now, what this implies that r value will be equal to 0 and 1. 0 or 1 it will be. Okay. Now, putting r is equal to 0 in equation second. Now, if you're going to put r, then what it will be? 2q. Okay. So, you can see 2q. So, 2q will be divisible by 2 or not? This will be?
Yes, ma'am. It will be divisible by 2.
Divisible by 2 because it is a multiple of 2. So, it will always be divisible by 2. And now, when we will put r is equal to 1, so a is equal to 2q plus 1. Since 2q is divisible by 2, so if you are adding 1 in this will not be divisible by 2 and it will become an odd number because all the even numbers are divisible by 2. Okay. So the odd numbers are what? Plus every positive integer is either of the, you can say this is 2q plus 1, which is not divisible by 2. So you can say, what was the question? So you can say here from here that every positive integer is of the form 2q and you can write this complete statement from here. Thus every positive integer is either of the form 2q or 2q plus 1. Okay. Understood, Shazan?
Yes, ma'am. Getting it.
Okay. Now similarly, show that the square of any positive integer is of the form 4m plus 1. Okay, many time it will not happen, you will get just directly that exact value. Okay, so here we will be assuming some value as m. Okay, have you done these questions?
No, ma'am. In our school it happened, but I didn't understand the chapter properly. That's why I just did some of the questions like which I understood that ones.
Problem. So what is it in here? Show that the square of any positive odd integer is of the form 4m plus 1 for some integer m. Okay, for any integer. M can be any integer. It's not written anything, but m will be any integer. Integer value means you know already the integer definition of integer. Okay, it will be from 1 to. Okay, so all the numbers that can be represented on number line. Now, again, we will be taking two numbers, two positive, let A and B be any odd integer. Now, you take A as a positive odd integer, okay? Because it's mentioned here, let A be any positive odd integer, okay? Now, dividing A by B, dividing. Now, what we will get? From Euclid's division lemma, A is equal to BQ plus R, and R value will be greater than equal to 0 and less than B. Okay, this you take it as equation 4 and write by Euclid's division lemma. Okay, by Euclid's division lemma. Now, we have got this. Now, on putting B is equal to 2. Okay, B is equal to 2 in equation first, we get what you will get. A is equal to 2q plus R. Now, R value will be equal to less than 2. Okay, now this will imply what? That R value will be equal to 0 and 1. Okay, now one by one we will put. If R is equal to 0, then what will be there? That A is equal to 2q. Yes, which is divisible by 2.
Yes, ma'am.
Since it is divisible by 2, so it will be even.
Okay.
Okay. And if R is equal to 1, then what you will get A is equal to 2q plus 1. So 2q plus 1, this it will be odd number because it will not be divisible by 2.
Yes. Yes.
Okay, so
Okay.
2 plus 1 is odd. Okay, now what it is telling that show that the square of any positive odd integer is of the form for square of any positive odd integer. Now we are going to do square of this. Okay, now if you are going to do square, A square is equal to 2q plus 1 square. Okay, as A is odd, so this one is odd now. So we are going to do the squaring of this. So what you will get, that it will be equal to 4q square plus 4q plus 1. Yes, so you can write 4 common q square plus q plus 1. Yes or no? So you can write 4m plus 1 where m is equal to q square plus q. Okay,
Okay.
okay.
Yes, ma'am.
For some integer m, for some integer m, the square of any odd integer is of the form 4m plus 1. Okay, understood? Zan?
Yeah, I'm getting it little.
Riya is not there, no?
Yeah.
These questions are little, what is
And can I do again one simple one? And so I'm just having some more doubts. Can you just explain just once again? Then it will all be clear.
the last one?
Yeah.
This one?
Yes, ma'am.
Okay, see, hello Ria. Okay, so I'll explain in fact both because Ria is also here. Else it will just give me 2 minutes more so that Ria settle. Okay, so Euclid's division lemma. So what is Euclid division lemma? It is nothing much special thing. It is you can say Euclid division lemma tells us about the division of integers. Okay, division between integers. Okay, so we have been dividing integers to integers already, and there is a long division method we have been following. Okay, what is long division method? That is dividend is equal to divisor multiplied by quotient plus remainder. Okay, and we represent it as A is equal to BQ plus R, where A and B are any two integers. Okay, so we take Q and R. Q is the quotient and R is the remainder. Okay, now remainder should always be less than B and greater than equal to 0. So 0 Euclid's division lemma. Now we have done a question here That is the application of Euclid's division lemma. Okay, you will get question based on application of Euclid's division lemma. Now, first question was what? Show that every positive even integer. Okay, Shazan, see, you have to show, and Ria, you also show that every positive even integer is of the form 2q. That means that all the positive integers, okay,
Yes. Yeah.
even integers, every positive even integer is of the form 2q. You can
Okay.
represent it in the form of 2q. Okay.
Okay.
In fact, we know if you can write 8 as 2 into 4, you can write 10 into 2 into 5. Okay. So all the positive even integer is of the form 2q. You have to prove that. You have to show this. And then every positive odd integers, all the positive odd integers is of the form 2q plus 1, where q is an integer. Okay. Q is any integer. Okay. Now we are taking here a and b, any two integers. Okay, any two positive integers, because we are talking about positive numbers only. We are talking about positive numbers. Okay, so I'm taking a and b, any two positive integers. Okay, now Euclid's division lemma, whenever we are applying this here, a is greater than b. Okay, so I mentioned that a is greater than b. We are taking two integers a and b, where a is greater than b, so a will become the dividend. So what will be the applying after applying Euclid's division lemma? We'll get a is equal to bq plus r. And what will be the value of r? R value will be equal to or greater than 0, but it should be less than b, the value of b. Okay. Now we are putting the value of b as 2 in the equation. Okay, understood? So value of b, we are the minimum value of b we are putting. If you will put 1, so value of r will become 0 indirectly. Okay, so I am putting value of b as 2. Now, if you are going to put the value of b as 2, you'll get a is equal to 2q plus r, and r value will be greater than equal to 0 but less than 2. So less than 2 means what is the means how many values r will have? R will have 0 and 1. These two values. Now, one by one, I am putting the value of r in the equation first. Okay, in the second equation. So when I have put the value of r as 1, sorry, 0 in this equation, so I got a is equal to 2q. Now, when I have got r, a is equal to 2q, so you can see 2 is 2 and q is there. 2 has been multiplied with q. So since 2 is there in this, that means 2 is a factor. It will become a factor or not. So that means it will be divisible by 2. Yes or no? If I write here 2 into any number, 5, 10, 15, 16, 20, will that number be divisible by 2 or not? Yes, it will be divisible by 2.
That form it will be divisible.
So a is equal to 2q will be divisible by 2. Okay. Now when I'm putting r is equal to 1, so a is equal to 2q plus 1. Okay. Because yes, Ria.
I just had to check whether you could hear me.
Yeah. So a is equal to 2q plus 1. So you can clearly see that 2q plus 1. 2q was already divisible. Okay. From 2. So if you are adding 1 in this number, so what it will be? It will become an odd number and it will not be divisible by 2. Obviously, 2q is divisible. So if you are adding 1 in that, so it will never be divisible by 2. Okay. So you can see that all the even, what was there? All the even positive integers. All the even positive integers is of the form 2q, and all the positive odd integers are of the form 2q plus 1. Now understood, Shazan?
I did.
And Ria, have you understood this one? Now, show that the square of any positive odd integer is of the form 4m plus 1. Okay. Now, okay, we have to show that square of any positive odd integer. It is talking about only positive odd integers. Okay, is of the form 4m plus 1. Okay, you can express this as 4m plus 1, and here m is any integer. Okay, now we are again taking a and b. Okay, now here we are taking a. Okay, because it is asking you about any positive odd integer. Okay, so I am taking a as a positive odd integer. Let a be any positive odd integer. Okay, and we are dividing a by b. Okay, I'm dividing a by b. Now, if I'm dividing a by b, so I'll get a is equal to bq plus r. Okay, where B is an integer and A is an even a positive odd integer. Now Q will be the quotient, R will be the remainder, but the value of remainder will be in the range from 0 to B, but less than B. Okay, it will be always less than B and greater than or equal to 0 from Euclid's division lemma. Now you can, I am going to put B value as 2 here, okay, in equation first. So what we will get, the variation of R will be from 0 and 1. Only 0 and 1 will be the values of R because B value is 2. Now one by one I'll put the value. So R is equal to 0. When I put R is equal to 0 in this equation, so what I will get? Only 2q because R is 0. So 2q we already know is divisible by 2. So when a number is divisible by 2, so it will always be an even number, that we know. So A is equal to 2q is an even number. Now if R is equal to 1, so A is equal to 2q plus 1. So still 2q is divisible by 2. So 2q plus 1 will be not divisible by 2, and that becomes an odd number. Okay, all the numbers that are not divisible by 2 are odd numbers. Okay, now it was given in the question to square any positive odd integers and represent it in the form of 4m plus 1. So we got an odd number. A is equal to 2q plus 1. So we are going to do square. So when you do square, A square is equal to 2q plus 1 whole square. So that will be, you will be opening with the formula A plus B whole square is equal to A square plus 2AB plus B square. Okay, opened it. Now what I have done, I have taken 4 common from both q square plus q plus 1. So I can represent this as 4m plus 1, where m can be represented as q square plus q, which will be a integer. Okay, because it is already mentioned q can be some integer. Okay, any doubt? Shazan, Ria now? Shazan, have you understood? You asked me to explain again.
Yeah, I did get it.
You didn't get it.
I did get it. I'm understood.
Okay, Ria, what about you?
Yes.
Oh, no, something like that, but it is just happening. Oh, now what is the question? Show that the cube of any positive integer. Now this time positive integer is there and we have to do cube. Show that the cube of any positive integer is of the form 4m plus 1 or 4m plus 3 for some integer m. Okay. So now, do you want to try? How can we do? Just tell me some steps. Shazan and Ria. Shazan, tell me. I have explained you 2 times both the question.
I'll just do it.
Any guess? First, tell me what you are going to take.
So that the Q of any positive integer.
Since positive integer, A will be any positive integer.
What?
It is talking about any positive integer. Na? So let A be any
Positive integer.
positive integer.
Ma'am, wait, why don't you give the sum to us? So we'll do it.
Okay, do it.
Now give 5 minutes for this sum.
Okay, both of you do, and you give me the screenshot. Click in the.
Oh, you want us to send it in the group, right?
Yeah.
Okay.
How I will check it, because this is a proof one. Now we don't have to get exact answer. You have to prove it.
Okay.
Yeah.
Can you explain this question?
Yeah. Show that the cube of any positive integer is of the form. I'll give you the hint. Okay. Is of the form 4m plus 1 or 4m plus 3. So you have to show that if you're doing cube of any positive integer, so it will be of the form, you can express it in the form of 4m or 4m plus 1 or 4m plus 3. Okay. Now we are taking any arbitrary number a, positive integer a. Okay. Now when you will apply the Euclid's division lemma, so what you will get? A is equal to 4q plus r. Yes, Ria? And R value will be again greater than equal to 0 and less than B. Okay. We take A and B. Okay. Now instead of B, I'm taking 4 here. Okay. You can see where 4 is there. So I'm taking A 4. Okay. Now, so R value will be greater than equal to less than 4. So R value will be here 0, 1, 2, and 3. 3 values will be there. Okay. Now it is telling you to cube of any positive integer. Okay, it's asking you to do the cube of any positive integer. So a cube will be equal to what? 4 cube plus 1 cube. Okay.
Ma'am, I have done till step I'm sending you. Like I think one or two steps you have to add in that, and you'll get the.
Uh,
Uh,
a plus b.
Ma'am, I'm sending you your number. Can you check?
Okay, just we are trying to do this. You expand this with cube formula. It will be a cube plus b cube plus 3a square b plus 3ab square. You have sent in the by Euclid division lemma b is equal to 4 42 plus 5 is equal to 0 42. Yes, Shazan, you have done for only one. Yes, 4 into
Yes, ma'am.
4m. You have represented only for 4m. So similarly, when you'll go till 3 now, so you can represent it in the all the 4m plus 1 and 4m plus 3 also. Okay, understood?
Yes, ma'am.
You could think in or you could think in
Okay, so let me explain, Ria. Okay, now just wait a minute, I will explain again. So I think Shazan you already understood. Now,
Yes, ma'am.
okay, Ria. So what was there? We'll be taking let a be any positive integer. Okay, okay, and b is equal to 4. Okay, now a is equal to 4q plus r, where r value will be greater than 4 by Euclid's division lemma. Okay, got it? Now r value will be equal to, this implies that r value will be equal to 0, 1, 2, okay, and 3. Now, if r is equal to 0, so what it will be? A is equal to, or first what you will do, we'll do the cube. First we'll do the cube and then it will be easy. Otherwise you have to reply every time. Okay, so cube will be equal to 4q plus r whole cube. Now, if you represent a plus b whole cube, it will be
plus 3 a square b plus 3b
yeah, a cube plus b cube plus 3a square b plus 3 a cube square. Okay, I should have written this also small. A plus b. Okay. Now, if I represent from here, if I open, so 3 plus r cube plus what is there? A square 16 into 3 will be there, no? Okay. Now we'll take if r is equal to 0. So if r is equal to 0, so what it will be there? A cube will be is equal to 64. 64. From here is the this one. From this one you check. Okay. So a is equal to 64 q cube. All the r will be 0. Okay, Ria? So you can now represent it as 4m. 4m. Yes or no? Where m will be equal to 16q cube. Okay, got it, Ria? Now, if r is equal to 1, if r is equal to 1, so a cube will be equal to 64 q cube plus r cube plus 48 q square r plus 12 q r square. Okay, so what you can do, you can take the this as common. Wherever you can take the 4 as common. Sorry, no, instead of not r, you will have to write 1 now. Plus 1. Okay. Now, what will be there? 4, you can take it as common. Okay, so it will be 16q plus 12q square plus 3q plus 1. Okay, so you can represent it as 4m plus 1. Here m value is this. Okay, understood? Slanting is going. If r is equal to 2, so r is equal to 2 means what? AQ will be equal to 64 QQ plus 96 Q square plus 48 Q plus 8. So you can write it as A cube as 16 QQ plus 24q square plus 12q plus 2. So what you can write? AQ as 4m again. Yes or no?
Yes, ma'am.
Okay. Now if R is equal to 3. If R is equal to 3, so it will go. R is equal to 3, it will go little big number. 64q cube plus 108 108 cube plus 144q square plus 27. Okay, so this can be represented as 4m plus 3. Now understood, Ria? So you can see all the numbers can be represented as 4m, 4m plus 1 or 4m plus 3. Okay.
Yes, ma'am.
Now try this question also. Try to. Now what do you think? How can we do this one?
And A would be a positive integer.
Yes, Ria?
But where is A? And A could be any number, any integer.
What is the question? Show that one and only one out of n plus 4, n plus 8, n plus 12, and n plus 16 is divisible by 5, where n is any positive integer. Is divisible by 5. Means among this, only one of them will be divisible by 5. Yes, where n is any positive integer. So now we should take any positive integer. Yes. So okay, now n is what? Already number is given here, na? Given numbers are, what are the numbers? N plus 4.
N plus A plus 12 and N plus.
Okay. Now, and on dividing n by 5. When you are dividing n by 5, so let q be the quotient and r be the remainder. So when you are dividing n by 5, n 5q plus r, where r value will be greater than equal to 0 and less than 5. Okay, from Euclid's division lemma. Okay, now which implies that what will be the value of n? N will be 5q plus r, where r value will be equal 1, 3, 4. Okay, now what it will be? N value will be equal to 5q or 5q plus 1, 5q plus 2, 5q plus 3, and 5q plus 4. Now, if you take n is equal to 5q, okay, then n is only divisible by 5. Okay, n is only divisible by 5. If you take n is equal to 5q plus 1, okay, then 5q plus 1, then n plus 4. N plus 4, which will be equal to, n value is what? 5q plus 1 plus 4, which will be equal to 5q plus 5, 5 common, q plus 1. Okay, which will be divisible by 5. Okay, so only n plus 4 will be divisible by 5. Okay, if you take n is equal to 5q plus 2, then n plus 8. Yes, no? N plus 8. N plus 8 will be equal to what? 5q plus 2 plus 8. Okay, it will be 5 common, q plus 2. Okay, so then only this n2 plus 8 will be n plus 8 will be divisible. Similarly, you keep on going. Okay, you can see here that only one at a time will be divisible. One and only one out of n plus 4, n plus 8, and n plus 12, or n plus 16. So 16 is divisible by 5. Understood, Ria?
Yes, ma'am.
Shazan?
Yeah, I'm getting.
You'll find many questions in your assignment also.
Now I have to do some questions in order to get.
But Shazan?
Mama said I have to practice some questions to get it.
Yeah, okay. So I'll assign you the assignment tomorrow. Okay?
Okay, ma'am.
So what sir is teaching right now?
Triangles.
I think he will be taking triangles. So you ask him to teach you area of circle or what?
Okay.
I don't know about it. Maybe he will be discussing with you what chapter to go on.
Okay.
Okay. So in triangle, Sarah has taken 3 classes, 2 classes.
What, ma'am?
How many classes Sarah has taken of triangle?
Ma'am, 3 or 4, I think.
3 or 4 classes. Yes.
Three classes.
How many, Ria?
3 classes.
3 classes. No assignment you have got of triangle, na?
No.
Okay, so then I will ask sir. So I will assign on Monday. I'll assign you the triangle or whichever chapter. Okay. I'll ask you. Okay. So tomorrow I will give assignment on this and we'll discuss it also in the class. So that way your queries will also be solved. Okay. Many questions will get there. Okay. Now what is this? Euclid's division algorithm. Okay. Now in algorithm we will be finding the HCF. Okay. It is a technique where you get to find out the HCF between 2 or 3 given positive number integers. Okay. Now, how can we do that? We already know the what is the division lemma. A is equal to BQ plus R. Okay. When A is divided by B, so we'll get a quotient Q and a remainder R in such a way that R value will be less than B and equal to or greater than 0. Okay. Now, how do we find it? When you're finding the LCM, so you have to take note that it is but how many times you'll be dividing. If R is equal to 0, then the HCF is B. Already know. Okay. And if R is not equal to 0, then we'll apply Euclid's division lemma to B and R. Okay. When you'll see the question, then you understood. Then we apply the division lemma to B and R. Okay. Now you have to continue this process till then the remainder is becomes 0. Okay. Then at that stage, what number you get? What is the A and B? That is your HCF and HCF. Okay. Now, one of the question here. Now, Euclid's division lemma always A should be greater than B. So here A I'm taking at 3A220 and B as 176. Okay. So now we'll be applying division lemma. So sorry, algorithm. So what will be there? Divided by 176. So how many times it will use? Can you tell me? 38220 divided by 76. 70. Okay. So 217. Okay. So when you're going to subtract, I'm getting remainder as 28. Okay. Still the remainder is not 0. So what it will be there? We'll be applying on B and R. So here B is this and R is this. So the B becomes the R. Sorry, the R becomes the B and your B becomes the A. 76. Okay. Now the 28 we again divide 8. Now again the remainder is not 0. So we'll again apply 8, 28. Okay. So here again the remainder is not 0. So we'll apply. Now here the remainder becomes 0. So what is the LCM here? Sorry, HCF here. 4 is the LCM, HCF. Okay. Remainder becomes 0 and last divisor is 4. So HCF of 176 and 38220 is 4. Okay. Understood or not?
Yes, ma'am. Understood.
So you have to write the statement also when you are doing an exam. Okay. So I'll give you one more question to try. Try this. Okay, sorry, I was on mute. Okay, so the answer is 48. Yeah, you can note down Shazan. Okay, after the class, you can check it. Okay, ma'am is already here, and my class is also there. So I'm leaving. Okay, I think you understood. Yeah?
Yes, ma'am.
Okay, so 2-3 questions we'll do of this in the next class, and then we'll be in the fundamental theorem of arithmetics. I mean, the tree one is there, factor tree is there. Okay, then, bye-bye.